In this mini research sample, the title is The Performance of Grade 10 Students in Mathematics at IPSJ in Third Quarter, School Year 2022-2023. The first part is the statement of the problem, and this is how it looks like. This mini research will help the researcher determine the performance of grade 10 students in mathematics at IPSJ for the third quarter school year 2022-2023. In this part, this is where you want to, where do you want or what do you want to know in your research. So in here, the researcher wants to determine the performance of the students in grade 10. The next part is the background of the study. So in this part, this is where you want to tell something about your research. So this is my example. Mathematics is an essential part of the school curriculum, as it is used in both daily life and the study across the other fields. However, it is widely held that most students dislike mathematics. Many students struggle academically and are not interested in this subject. Hence, teachers must identify which students are having difficulty and intervene to assist them in overcoming these concerns. So the next part is the significance of the study. This is my example. The researcher may be able to identify students who need support and intervention in this subject. So this will reveal whether or not the students are having difficulty with mathematics. So in this part, this answers why do you want to conduct this study. This will tell you the reason and the relevance of this research. So take note of this line because we're going to answer this based on the result of our methodologies in the later part. This part of methodology, this is where the specific procedures of tests used to identify, select, process, and analyze information about the topic. So these are the parts of methodology. The research design here is quantitative because you want to try and apply different statistical tests, particularly the measures of position. So the instrument that will be used for data gathering here is documentary analysis. We will be using this for this mini research. Then our participants are grade 10 students at IPSJ. And in the data gathering, I will be taking teacher's class record. So for the students who would like to use the documentary analysis in data gathering, so they need to prepare a formal letter because they cannot just take teacher's class record. So you need to request it by making a formal letter. Then for the methodology, for our statistical treatment, I will be getting the percentiles and the percentile rank of the data. For example, this is the data given by the teacher. So I have here 104 participants. So of course, before we find the percentiles and the percentile rank, we need to prepare the frequency distribution table. So I know that you are still familiar with this since it was just our recent topic. So our step 1 is to find the range. In finding the range, we'll just simply subtract the highest and the lowest number from our data. So the highest number here is 98, the lowest number is 73. 98 minus 73 is 25, and this is our range. Step 2, we're going to find the number of classes. In here, we'll be using the 2k rule. So in this 2k rule, this 2 raised to k expression, the value of this expression must be more than the n. Since our n here is 104, so what will be the value of this k? By the way, this k represents the number of classes. So let's have a trial and error here. So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, and finally 2 raised to 7 is 128. So therefore, the value of k, so that the expression 2k becomes more than 104, the k must be 7. So the 2 raised to 7 is 128, and it makes the inequality correct. So therefore, our k here is 7, and that is the number of our classes. Step 3, we're going to find the class width, and that is simply by dividing the range, which is 25, and the number of classes, which is 7. So 25 divided by 7 is 3.57, and our class width is 4 by rounding it up. And we are now ready to draw the frequency distribution table. So we have here 1, 2, 3, 4, 5, 6, 7 classes because we have 7 classes for this data. So we will start writing from the smallest number, and that is 73. Then to get the next class, lower class interval, we're going to use the class width. We'll just keep on adding 4. So 73 plus 4 is 77. 77 plus 4 is 81, plus 485, plus 489, plus 493, plus 497. Now, to complete our class interval, we're going to write the upper class interval. So that is just simply subtracting 1 to the next higher interval. So 77 minus 1, that is 76. Then we keep on doing that. 81 minus 1, that is 80. Or we can also keep on adding the class width. So 76 plus 4 is 80. 80 plus 4 is 84. Plus 4 is 88. Plus 4 is 92. Plus 4 is 96. Plus 4 is 100. And we're done with our class interval. Next is to tally the data in our table. So in here, 94 is located in this class. Then 88 is located in here. 85 is also located in the same class. If you keep on doing this, this is how it looks like. Then count the tally for our frequency. So this is 7, 19, 31, 26, 11, 7, 3. And if we're going to sum them up, they should be equal to the number of our respondents or participants. Then we're going to add 2 more columns for our lower class boundaries and cumulative frequency. So for the lower class boundary, recall that we will just simply subtract 0.5 to our lower class interval. So 73 minus 5, and that is 72.5. 77 minus 0.5 is 76.5, so keep on doing that to complete our lower class boundaries. Now for the cumulative frequency, we'll just focus on the frequency, and we'll start from the smallest, and that is 3. Then keep on adding the next frequency. So 3 plus 7 is 10, 10 plus 11 is 21, 21 plus 26 is 47, 47 plus 31 is 78, 78 plus 19 is 97, 97 plus 7 is 104. So the highest cumulative frequency, again, must be equal to our number of participants. So far, we are already done with our frequency distribution table, and we are now ready to use it to solve for the percentile. Now, as a researcher, I am interested to find the 25th percentile of the data. So using this formula, okay, so we will just simply identify the following variables. So our W here, or width, is 4. We have taken this a while ago. Then our I here is 25 because we're looking for the 25th percentile. Our N here is the number of participants, which is 104. Then we're going to solve for K, K times N, the cumulative frequency, the lower boundary, and the frequency. So K is equal to I over 100. And our I is 25, so our K is 25 over 100. Then our Kn will just simply multiply N times K. So since K is 25 over 100, our N is 104. So 25 times 104 divided by 100, this gives us 26. So our Kn is 26. Now, we're going to locate this 26 in our cumulative frequency. Which of this class that contains 26? So, of course, these are 47, 78, 97, 104. But we want to know the smallest cumulative frequency. And this is 47. So therefore, we are referring to these classes. So this is the class that contains our Kn, which is 26. So our cumulative frequency here is the cumulative frequency less or lower than the next lower than the class, and that is 21. That's why our CF here is 21. Our lower class boundary is the lower class boundary itself of the class. Then our frequency is also the frequency of the class. That's it. It's 26. So we are now ready to use the formula. Substitute, use our calculator, and our 25th percentile is 85.27. So this is our interpretation. Therefore, 25% of the students, which is 26, has an average grade of 85, while 75% of the students, which is 78, has an average more than or equal to 85. So now, since we know that 75 is the passing score, so it means if you will get less than 75, it means you are failed. So in here, I want to know the percentile rank of 74 because I want to know what is the percentage of those students who got failed. That's why I want to know, I want to get the percentile rank of 74. So in order to solve the percentile rank, we will be using this formula. Then identify our P. Our P is equal to 74 because I want to know the percentile rank of 74, which is the less than 75. So our W is the same. This is 4. Our N is 104, the number of respondents. Our cumulative frequency is the cumulative frequency where 74 is located. So in here, 74 is located in this class interval 73 to 76. So this is the class that we are referring. So the cumulative frequency must be lower than the class. So lower than this class is none. So therefore, our CF here is 0. Then the lower class boundary is the lower class boundary of this class, which is 72.5. And we are now ready to use the formula. So write the formula, then substitute the given, and our percentile rank is 0.04087%. Or let us express this in one decimal. So that is 0.4%. So therefore, 0.4% of the students, and that is 1, if we're going to round it up, has an average grade of less than 75, while the other part, that is 99.6% of the students, and those are 103 of 104, they have an average of more than or equal to 75. Okay, so we're going to lay down the results and our findings. So 25% of the students has an average grade of 85, while 75% of the students, those are 78, has an average of more than or equal to 85. 0% of the students has an average grade of less than 75, while 99.6% of the students, which is 103, has an average of more than or equal to 75. So from these results, we can now form a conclusion. Based on the results, the grade 10 students got a very high mastery level of performance for the third quarter in mathematics. And a large part of the students, so these are the 99.6%, a large part of the students have an average of at least 85, and the passing rate is almost 100%. Look at this, 99.6 is almost 100%, which indicates that the students are not having difficulty in mathematics for this quarter. So this answers the significance of the study a while ago, the one that we have mentioned in our significance of the study. So what will be our recommendation? So the math teachers must retain the teaching strategies used in the classroom in order to maintain or intensify the high academic performance of the student in each quarter.